This lecture continues our study in Chapter 1, and we're going to move in now to Section 1.4. And this is about segments and their measures. All right, so we have two objectives in this section. We want to understand first the measure of segments, and then we want to use the segment postulate and algebra to find segment length. So those will be the two things we'll work through on these slides. All right, so postulate 1.4, this is the one ruler postulate. Postulate 1.4-1, this is the ruler postulate. The points on a line can be paired one to one, right, with a real number. What that means is that point A has one real number, we'll call it like 5 or whatever. And the real number corresponds to a point and is called the coordinate of the point. What this really does when you have 2 points like this and they each have a corresponding real number, this allows us to calculate the distance. Right? The distance between 2 points A and B is the absolute value of the difference of their coordinates. The reason we say an absolute value is because you can't have a negative distance, so you always have to make it positive. All right, so we use the notation AB. So notice that A and B stand for the points, point A, point B, but there's nothing over it, no segment or no line. All right, so we use the notation AB for distance or the length of the segment AB. So note the color here, this is important. The distance from A to B is equal to the value of the back point. So B goes first here, minus the value of the first point, right? And that's just the distance between the two. All right, let's do an example. Let's find MP. So it looks like M has a coordinate of -11 and P has a coordinate of 5. All right, so let's walk through it. Recall that MP is the distance between points M and P. So let's use the ruler postulate to find MP. All right, so as I said, the coordinate of M is -11. The coordinate of P is 5. So MP, remember, P, you start with the back, is 5 minus the first point, M, which is 11. So minus minus becomes positive, and that becomes the absolute value of 16, or the distance between the points is 16. Now forgive the slides, there's a little typo here. This is supposed to be PM, so forgive that. PM. PM is equal to the bottom coordinate M minus 11 minus the top coordinate P, which is negative, which is 5. So minus 11 minus 5 is minus 16. And that's still equal to just the absolute value of -16 is still 16. So the distance is 16 units. All right, two segments that have the same length are called congruent segments. Right, so two line segments that have the same length are congruent, and we use this symbol equal sign with a squiggly over it, right? This means congruency, or they're congruent. All right, so congruent segments versus equal lengths. If two segments A and B are congruent, then what that's saying is the distance is equal. Also, if the distance is equal, then the two segments are congruent. All right, so we mark congruent segments in a figure with exactly the same number of tick marks. Let me show you what that looks like. All right, so use the figure to write congruent segments and the equal distances. What we're saying here is that segment AB is the same as segment DC, and the segment AD is congruent or equal to the same distance of segment BC. All right, so A and D are marked the same, so A and D and B and C are congruent, thus their distances are the same, and it's the same that I just walked through with AB and DC. All right, if BC right here is equal to BC right here is equal to 2 feet, then find AD. Well, they have the same distance, so that means AD is equal to 2 feet. Similarly, if DC is equal to 6 feet, then find AB. Well, they have the same tick mark through it. That means they're congruent, right? So that means they have equal distances. So if DC is equal to AB, so if DC is equal to 6 feet, then AB is also equal to 6 feet. All right, so given the figure, right, is segment BG congruent to segment AC? Right, so here's BG. It goes from -6 to 3, and AC goes from -10 to -1. All right, so remember, if the segments are equal, so if BG is equal to AC, then the segments BG will be congruent to segment AC. Right, so what I'm saying here is to show that two segments are congruent, what you should do is see if they have equal distance. So if we go through the distance formula with BG, so G here is 3 minus -6, that becomes 9, so the absolute value of 9 is 9. And then similarly with AC, we start with C, which is -1, minus -10, which becomes -1 plus 10, 9, 9. All right, so thus BG is equal to AC. Their distances are the same, so thus BG is congruent to AC. Let's do another postulate. This is postulate 1.4-2. This is about the segment addition postulate. So if point B is between A and C, excuse me. Now remember, B falls between A and C. Then AB plus BC is equal to AC. Also, if AB plus BC is equal to AC, then it has to follow logically that point B is somewhere between A and C. You can see this visually below. So up at the top here, or the bottom, excuse me, we have segment AC. B falls into it. This is segment AB, segment BC. When you add them together, you just get that whole segment AC. All right, so let's do some definitions. The midpoint of a segment is a point that divides or bisects a segment into two congruent segments. Right? So if you look here, we have some line M. Right? This intersects the segment AC at point B. And when we see these dashes here, remember that means this and this are congruent, all right, or equal distances. So it must follow then we have the following two statements. B is the midpoint of that line segment AC. Line M bisects AC, right? That means it divides it right in the middle. Line BD bisects segment AC. You see that visually there. Ray BD bisects segment AC. The two segments AB and BC are congruent. And then also AB is equal to BC. All right, the segments are equal distance. All right, a line, ray, segment, or plane that intersects a segment at its midpoint is called a segment bisector, just to fully define that. So like line here, line M is a segment bisector. Let's work some postulates. So let's use in the segment addition postulate. All right, if MP, so segment M to P has distance 47 units, let's find MN and NP. And I don't tell you how far they are, but I give you some algebraic expression. So here's how you would solve it. You would go MN plus NP is equal to that MP. Well, look, MN goes in there, 5x plus 1. 11x minus 22 goes in for NP, and that's equal to 47. Combine like terms, like 5x plus 11x is 16x. 1 minus 22 is equal to 47. So add the 1 over, 16x is equal to 48. Divide by 16, and you get x is equal to 3. Now that's not like the end of the problem. What you have to do is then plug this back in, all right? Use that value of x to find what M and N and NP are. So Mn, wherever you see an x, plug in a 3. This line segment right here, Mn, is equal to 16. And similarly, Np, plugging in 3 into that algebraic expression right here, you see that the segment Np is equal to 31. All right? And you can check it. 16 plus 31 is indeed 47. All right, finding the midpoint. Point C is the midpoint of segment AB. All right, so let's find AC, this segment here. Let's find CB, and then let's find AB. This one's a lot harder. So what we got to remember, if it's the midpoint, that means the two sides, the two segments have equal distance. So let's set these two algebraic expressions equal to each other. So AC, segment AC, has to be equal to CB. Substituting in. Next, what we're going to do is we're going to subtract the 7x over from both sides. We'll add the 6 over next. We get 9. All right? So that's just what x is equal to. Now what we have to do is use that x to find what the actual distances are, right? What AC is, CB, AB. Right, so use the value of x to find AC, CB, which should be the same. So AC, wherever you see that x, we're going to plug in 9. Get 72 minus 6, which is 66. So by extension then, CB, the other line segment over here, has to be the same exact thing. Let's just check that. Plugging in 9, indeed it does equal 66. And now we can finally find what AB is equal to. We just add the two segments together using the segment addition postulate. 66 plus 66 gets me 132.